Imagine a world where you can upload a picture or type a few words into an AI program, and in return, you receive a full-fledged video complete with sound, music, or even an intricate story. This might sound like a distant dream, but it's not. We're already there, thanks to Microsoft's groundbreaking AI model, CoDi. CoDi, an acronym for Composable Diffusion, is a multimodal AI model. This means it can simultaneously process and generate content across multiple forms or modalities, such as language, image, video, or audio. But what sets CoDi apart from existing generative AI systems is its versatility. It can generate multiple modalities in parallel, and its input is not limited to a subset of modalities like text or image. CoDi can take any combination of input modalities and generate any combination of output modalities, even if they are not present in the training data. This opens up a world of creative possibilities that were previously unimaginable. At the core of CoDi's functionality is a technique called diffusion models. These models learn to reverse a diffusion process that gradually adds noise to the data until it becomes random. For instance, if you have an image of a cat, you can add some noise to it until it becomes unrecognizable. Then you can train a model to remove the noise and reconstruct the original image. Diffusion models have proven to be very effective for generating high-quality images. But CoDi takes diffusion models to the next level by extending them to multiple modalities and making them composable. Composable, in this context, means that CoDi can combine different diffusion models for different modalities into one unified model that can generate any-to-any outputs. For example, CoDi can combine a diffusion model for text with a diffusion model for image and a diffusion model for audio into one model. This unified model can then generate text from an image from text, audio from text, text from audio, image from audio, audio from an image, or any combination of these. It achieves this by learning a shared diverse space for all modalities, mapping all modalities into a common representation that preserves their diversity and uniqueness. To learn this shared diverse space, CoDi uses two key components: latent diffusion models, LDMs, and many-to-many generation techniques. LDMs are diffusion models that learn to map each modality into a latent space that is independent of the modality type. Many-to-many generation techniques are methods that enable CoDi to generate any output modality from any input modality. By combining LDMs and many-to-many generation techniques, CoDi can learn a shared diverse space that enables composable generation across multiple modalities. So, what can CoDi do with this incredible capability? CoDi can do a lot of cool things that no other AI model can do. It can take in single or multiple prompts, including video, image, text, or audio, and generate multiple aligned outputs. For example, given a text prompt that says, "Teddy bear on a skateboard, 4K high resolution," an image of a teddy bear, and a sound of a skateboard, CoDi can generate a 4K resolution video of a teddy bear on a skateboard with the sound of the skateboard. But why is an AI model like CoDi so important? CoDi is important because it breaks down the barriers between modalities, enabling a more natural and holistic interaction between humans and computers. It can help us create dynamic and engaging content that can appeal to multiple senses and emotions. It can also help us access information and express ourselves in different ways that suit our preferences and needs. For instance, it can help create accessible technology for people with limitations, generate captions for videos or images for people who are deaf or hard of hearing, generate audio descriptions or text summaries for people who are blind or visually impaired, and even generate sign language videos or images for people who use sign language as their primary mode of communication. Another example of CoDi's potential applications is in the field of education. It can create special tools to help different types of learners, adjusting content to match what a learner knows and wants to achieve. Plus, it can make content that suits learners' interests and likes. CoDi is also affordable and easy to access. It does not require expensive hardware or software to run. It is actually available as an Azure Cognitive service that anyone can use through an API or a web interface. It is also scalable and flexible and can handle any combination of modalities and generate any-to-any outputs. In conclusion, CoDi is a revolutionary AI model that can generate anything from anything, all at once, through composable diffusion. It is leading us into a new era of generative AI that can enrich our lives and experiences in ways we've never thought possible. Thanks for watching.